Okay, so this is about CPU and machine code. So there's a few things here that you need to know for the A-Level OCR syllabus. The first one I'm going to show you is the different components of the von Neumann architecture. The other thing you need to know, which is a separate article, which I've also linked in this article, so everything is linked below, is about the difference between Harvard and von Neumann. So you can read this and but mainly focus on this one. And I'll put the Harvard versus von Neumann in a different video. So what is a CPU? Well, it contains lots of different registers and buses and components that basically help you calculate anything. The main components of it are, let's just jump straight to the diagram. So you've got your CPU here, then you've got memory, data, registers, and you've got buses that pass information to and from the CPU to the main memory. You've got a data bus and address bus. And then you've got a control bus, controlled by the control unit, and the control unit tells the RAM and other components what they need to do, whether they need to read from, whether the RAM needs to read basically or write from memory. And then inside of the as well as these registers in the CPU, you've also got other ones like the program counter, next instruction to be fetched, the current instruction register, which is the current instruction that you're going to fetch from, which you've just fetched and you need to decode, and the address register, which is the memory address register, which is will hold either the most recently fetched address from RAM or the next instruction, the address of the next instruction to be fetched, which is copied from the program counter. And then you've got the accumulator. The accumulator will hold the results of any calculations which the arithmetic logic unit will do. The best way you can understand this, which you should do with me now while you're watching it, is to look at the article, open up this little man machine. I'll also put a link for that below, and copy this very simple program here. And all this program does is ask for two inputs and adds them together. So if we go over to the little man machine, let's if I clear this, reset, let's reset that. Right, basically paste it, the program in, submit it, and then it will compile it into the memory. Once you compiled it, you'll see all these instructions in the computer's RAM over here. And when we press run, you will see a blue dot or a red dot running around. The red dot is an address, and the blue dot is usually an instruction or data that we're either fetching from the RAM or something that we're carrying from the accumulator to the main memory. You will need to understand all these instructions. So this is the list of the different instructions I'm going to talk to you about. So let's just run this program. And basically all this program is, we've got this instruction IMP. So if I look it up on this lookup table here, this key, IMP is input or output. So there are two parts of IMP, right? When you look at what's actually in the main memory, you have this number 901. What that means is the first number 9 is the instruction, that means input. Well, either input output, and 01 is the so if you read it here, it says 9 is input or output. Take from input if the address is 1, okay? Copy to the output if the address is 2. So you've got the address part here. So if it's 01, it's take from the input, and if it's a 902, which is like the second to last one, then it means output what it is over there. So you've always got the first digit is the instruction 93919, and that they do different things like input, store, load, add, and then the second two digits are the address. So let's just run this, and I'm going to slow this down by using these arrows and really slow it down. The first thing that happens is the program counter gets updated by adding 1 to 0, so it becomes 1 in the arithmetic logic unit. The first address, which was in the program counter, 0, is sent down the address bus, and it goes into main memory, and it will fetch the instruction that is as a main address 0. That instruction 901, which, as I said, is input because it's 901, is sent down the data bus. They don't show the buses in this, but they don't show the separate buses. You just have to assume that when you see the blue dot, it's the data bus. And that gets sent, I can speed this up a little bit now, that gets sent into the CPU. The address of that instruction is stored in the memory address register, and the instruction is stored in the current instruction register. So here is a list of all the things, and you need to read this and get it in your head, but just doing the example will help you learn it way better. So we've already looked at the program counter, which holds the next instruction to be fetched, the memory address register, which will hold that address just fetched from memory, or we're going to go and get something from memory at that address. The address bus is this unidirectional bus. You send addresses down it into main memory. That's what happens with the red thing moving. And then we've got the control unit and the control bus, and they basically coordinate whether the main memory is going to read or write. And the data bus, which you get the blue thing going down, is the bidirectional bus that goes into and out of memory. The memory data register will store any data that we have fetched from memory. The current instruction register holds the current instruction that we're going to decode, what we need to execute, and the arithmetic logic unit will do calculations, and the accumulator will store them as a result. So you'll see the use of the accumulator now. So it's waiting for input. So I'm going to put 4, I press return. That 4, that bit of data is sent down a data bus into the CPU and stored in the accumulator. And then the next instruction is fetched from instruction 1. The program counter is updated by the arithmetic logic unit to be 2. The next instruction is 308. What does 308 mean? It means STO8. If you look that up, you'd see that STO or STA is store, and 08 is the address. So what that means is whatever is in the accumulator, we're going to store that at address 8. So let's put the address in memory address register, current, and 3 in the current instruction register, and then it sends the data 4 down the data bus and the address 8 down the address bus. And you can see that that is going to store 4 in number 8. And then the next instruction is fetched. So this is the fetch, execute, decode cycle. So we're fetching, fetch, decode, execute cycle. The next instruction was 901. So that's another input. So I need to input another number. So I'll input 7. That number 7 is stored in the accumulator. The program counter is updated. The next instruction is fetched at address 3, 108. What does 108 mean? Let's stop that. Let's go and look at the table again. 108 means add the contents of the memory address to whatever is in that address to the accumulator. So whatever is in memory address 8, which was 4, we're going to add that to whatever we've just input into the accumulator. So basically, we're going to do 7 plus 4, which is 11. And then it will go and fetch the last instruction, which is out, which is at address 4, 902. So 9 is input or output, but because it's 02, it means output. It's done the operation of adding 8 to 4. Run the last instruction. And 902 is executed, and 11 is output into the output window. And the very, very last instruction, halt, is fetched, decoded, and then executed, and it stops the program running. So there you can see how the von Neumann machine uses all the different registers and buses to communicate with the RAM. what this little man machine is, it's a bit oversimplified. It's good, but it doesn't show the control unit. It doesn't show the control bus. It shows the current instruction register and the memory address register, but it doesn't show things like the memory data register, which you need to, or it's one of the things you need to know about. Because stuff that is fetched from the RAM, data that is fetched from the RAM is stored in the data register, whereas addresses which are fetched from the RAM or from the CPU are stored in the memory address register. So there's actually two registers, one for addresses and one for data. So it doesn't show that, but it does give you a very good overview and idea of how the von Neumann machine works with all the buses, and you just have to kind of get that in your head. So there's one very simple example. Here's another task. Create a program that asks for two inputs and subtracts them, so you don't have to change much.